paper that we are covering today is specimen paper for additional mathematics. So for the first question here, this is from the polynomials topic, and they gave you factor of x minus 2. So this factor here play a key role. So from this factor, you will be able to identify when x equals to 2, there will be no remainder. So when you substitute 2 into x position, the results that you've gotten will be equals to 0. So by running the calculation, you'll be able to prove that q equals to negative 30. As for part B that we have over there, they want you to factorize it completely. So when you notice the keyword factorize it completely, means you're required to identify the exact value of x. So first thing that I did there was to divide 2x cubed minus 3x squared minus 30x plus 56 with x minus 2. So to cancel off 2x cubed, I multiplied 2x squared to the x minus 2 combination. Then I gotten 2x cubed minus 4x squared. This is the part where most students get confused. How did I get x squared as the balance? So at the column to the side, I draw a cloud-like bracket over there. So I show you that 2x cubed minus 3x squared minus bracket. So if you didn't include this minus bracket over here, then you will get something else, because the negative will be multiplied into the variables inside the brackets. So through this, I will get a balance of x squared, then I extract the negative 30 down, then multiply x into x minus 2, then I get x squared minus 2x. So the balance from this will be negative 28x, and I bring down the 56. So I multiply negative 28 with x minus 2 to cancel it off entirely. So from this calculation, you'll be able to get two brackets. One is x minus 2 and a quadratic equation of 2x squared plus x minus 28. However, this is not the results that the question is asking for. They want you to find the solution and factorize it completely. So you're required to run your factorization on the quadratic equation, and through that you will get your x final results as 2, 3.5 and negative 4 respectively. Question 2. You're required to differentiate the equation that goes by y equals to x square root x. So I changed the square root x into x to the power of 1 over 2, and with the x at the side, okay, since their base is the same, then I combine them up. Your y will now be x to the power of 3 over 2. So differentiate it by bringing out the power of 3 over 2. Then the x to the power of 3 over 2 is required to be minus by 1. So your balance from this will be 3 over 2 x to the power of 1 over 2, or you can write it as 3 over 2 square root x. In part B, find the approximate change in x when y increases from 8 by the small amount of 0.015. So this is the trickiest type for this kind of question. If they are asking for changes in x, that one will be the easier variation of this question. Okay, so a formula to remember is that dy dx equals to changes in y over changes in x. Okay, that's the first formula that I've written down. Then I proceed with my step 1, which is to identify my x value. So given that y equals to 8, so 8 equals to x to the power of 3 over 2. By running the calculation, I try to change my x to power of 1. So I multiply 2 over 3 to its power. So 8 after being multiplied with 2 over 3, you will get the results of 4. So having the x value as 4, we can now identify the dy dx exact value by substituting 4 into x position. Then you get 3. So with this step 1 and step 2 done, you take the 3 that you've gotten equals to changes in y as given by the question, 0.015 divided by changes in x. Cross multiply them and run your final calculation. You will get your results as 0.005. Moving on, we have question 3 over here. Okay, express 12x squared minus 6x plus 5 in the form of p bracket x minus q bracket square plus r. So by looking at this particular arrangement here, you should immediately know that they're asking you to complete the square. So to complete the square, the first thing that I did there was to extract the 12. Then we have a balance of x squared minus 1 over 2x plus 5 over 12. So as per usual, I only focuses on the two variables at the front. Okay, I try to identify what could possibly be the b value over there. Since it's negative 1 over 2x, I will know that the equation that we're using here is the x minus b bracket square variation. So I compare the negative 2xb equals to negative 1 over 2x. Run the calculation, then you get b equals to 1 over 4. So with this b equals to 1 over 4, we can now change, okay, and rearrange the equation into 12 bracket x minus 1 over 4 bracket square. So the next part is to solve the 5 over 12 that we didn't use. So the 5 over 12, since it is the outlier that we left out, so I multiplied with 12 again because I extracted it out from the bracket. Okay, so we added b squared. So we are required to minus it back out. So this is the part where students make mistakes because they've forgotten to multiply the b squared with 12. Okay, after the calculation, you should get 17 over 4 as the r's value, p equals to 12, and you have a q of 1 over 4. Part B. Find the greatest value of 12x squared minus 6x plus 5 to the power of negative 1 and state the value of which this occurred. So what this question is referring to is we are required to identify the turning point of this question. So to identify the turning point, okay, what we have there was the bracket. Okay, bracket of x minus 1 over 4. You set that equals to 0, then you get your x as 1 over 4. And when your x is 1 over 4, then your y's value will be 17 over 4. How did I know they are referring to the turning point? Because they mentioned about the keyword greatest value. Question 4, we have such question here. Okay, first thing that I did was to identify ax value because it is a right angle triangle, and through Pythagoras theorem, you'll be able to identify ax value as 3 square root 5. So they are asking for the area of the trapezium. So top plus bottom divided by 2 times height. So our top here will be 4 plus square root 5. The bottom will be 2 plus x divided by 2 multiplied with the height of 3 square root 5. And this equation here will be equals to 15 bracket square root 5 plus 2. So by running the calculation, okay, I get rid of the 2 first. Then multiply the 3 square root 5 into the bracket. rearrange them, you will get x equals to 12 square root 5 plus 45 over 3 square root 5. So remember, in surds we cannot leave square root as the denominator, so you're required to multiply square root 5 into both the numerator and denominator. By running calculation, you will get 60 plus 40 square root 5 over 15, and after the simplification, you will get 4 plus 3 square root 5 as your final answer. So for those who are not sure what I did over here, I drew an arrow at the side, and you can refer to the workings over there. Over at question 5a. So a lot of students struggles to draw this correctly. However, there's nothing complicated about this question. All you need to do is treat it without the modulus function. So I've written down y equals 2x plus 5 at the side. I set when x equals to 0, my y results will be 5, and when my y equals to 0, my x will be negative 2.5. So with this being said, I can now draw down the line. Okay, as you can see, there will be a dotted part at the bottom. For those, you are not required to include it. Okay, I just draw it out to show you as a reference. Okay, so the modulus function basically means your y value cannot be negative. So this entire thing that is stretching down to the bottom will now be reflected. So you see me drawing a V shape over there. So I repeat for the same on the equation y equals to 2 minus x. When x equals to 0, my y will be 2. When y equals to 0, my x will be 2. So similar V shape over here, reflected back up. Then you will get the answer. As for part B, both sides has modulus function. Okay, so nothing complicated about this. You're required to look at the front part first. So we have modulus function of 2x plus 5. Since everything inside is positive already, so you're required to do nothing over here. So for the one at the back, you're required to get rid of the modulus function and add plus minus bracket. So you get two results from here, which is 2x plus 5 equals to 2 minus x, as well as 2x plus 5 equals to negative bracket 2 minus x. Through the calculation, you will get x value equals to negative 1 and x value equals to negative 7. So I fill up according to the inequality sign. Your x will be less than negative 1, more than negative 7. Question 6 over here. Find the equation of the normals to the curve y equals to 2x minus 1 over square root of x squared plus 5 at the point where x equals to 1. Okay, so this part you can actually use the formula. Okay, the 2 given to you is actually your a. Then when you substitute 2 into the y's equation, you will get 1. So this 1 is when your x equals to 2. We call this f bracket a. So this is the first thing that I would do. Then I proceed with differentiating this equation over here. So since it is a fraction, so I'll be using quotient rule. Ux will be 2x minus 1 and my Vx will be bracket x squared plus 5 bracket to the power of 1 over 2. So I differentiate them, then I get u prime as 2 and v prime as x bracket x squared plus 5 to the power of negative 1 over 2. So through quotient rule, I listed down dy dx equals to 2 bracket x squared plus 5 to the power of 1 over 2 minus 2x plus 1 multiplied with x bracket x squared plus 5. This entire thing was divided by vx squared, which is x squared plus 5 bracket to the power of 1 over 2, then multiply this to the power of 2. Substituting x equals to 2 into it, then you will get 4 over 9. And the gradient of the normal will be negative 9 over 4. I then move on writing down the equation of the normal, which is y equals to fa minus 1 over f prime a bracket x minus a. So remember the a I identified earlier is 2, my fa is 1, my f prime a is 4 over 9, and 1 over f prime a is 9 over 4. Substituting it accordingly to the variables, okay, I multiply everything with 4 in order to cancel off the 9 over 4 over there. Rearrange them, then you will get 9x plus 4y equals to 22 as per requested by the question. Over in question 7, given that the area of the batch is 20 cm squared, show that the perimeters P of the batch is given by P equals to 2x plus 40 over x. So the first thing that I did was to construct the equation for the area because it is the only variables that was given to us. Okay, to get the area of the batch, we first have the circles over there. Why do I name it circles instead of semicircles? It's because the two semicircles joined up will become a circle. So instead of splitting it into two parts, I just combine them as one. So we have 1 over 2 times the radian of the circle, which is 2 pi, and the radius of x squared. I add it with x times y. This is actually the area of the rectangle shape over there, and this will get you 20. After the rearrangement, you will get pi x squared plus xy equals to 20, xy equals to 20 minus pi x squared, and y will be 20 minus pi x squared over x. Moving on, I'm calculating the perimeter. Okay, same thing, I combine this semicircle, so I didn't have two separate calculations for this. So I just treat it as a circle, 2 pi, which is the radian of the circle, multiply with x, plus 2y, which is AD and BC's length, and also the 2x over there, which is the other side of the semicircle. After the rearrangement, okay, I substitute y equals 20 minus pi x squared over x into the equation. Run the calculation, then you will get 40 over x plus 2x. And your final answer will be 2x plus 40 over x, as per requested by the question. Part B. Given that x can vary, find the minimum value of p justifying this value is minimum. So to find the minimum, you're required to differentiate the equation. So we have p equals to 2x plus 40x to the power of negative 1. I get rid of the x from the denominator because I wanted to use the product rule. Okay, if I were to keep it as a fraction, then I'm required to do quotient rule, which is more steps, more complicated, more time consuming. So to avoid that, I shifted it up and I gotten my dp dx equals to 2 minus 40x to the power of negative 2. So since they mentioned about minimum, this is when your dy dx equals to 0 or your gradient is actually 0. Run the shifting and calculation, then you will get your x as 2 square root 5. With this 2 square root 5, we can now identify p's value. Okay, So P equals to 2 bracket 2 square root 5 plus 40 bracket 2 square root 5 to the power of negative 1. And through this calculation, you will get 8 square root 5. Okay. Whenever you notice the keyword justify that this value is minimum, you're required to run your d2y dx2, which is your second differentiation. Through your second differentiation, you will get AD over x cubed. Substitute your 2 square root 5 into it, then you will get your results as 0.894427191. And this result is a positive, so it is a minimum. So in another way is when your result is negative, means that it is the maximum. Question number 8, part A. So this is the integration, or you call it integral. Okay, so what we have there was integral of 0.2 e to the power of 5x minus 1. So you're required to figure out what is its original equation. So there's no numbers at the front of e, means it is actually 1. So I set down y equals to unknown e to the power of 5x minus 1. The reason why I didn't change the power is because the rules that apply in exponential. Okay, so 5x minus 1, you're required to differentiate it, then you get 5. So unknown times 5 equals to 1. Okay, your unknown will actually be 1 over 5. So with this 1 over 5 here, okay, now we know that y equals to 1 over 5 e to the power of 5x minus 1. So substitute 1 and 0.2 into it, then you will get your final answer as 1 over 5 bracket e to the power of 4 minus 1. This is after the arrangement of extracting 1 over 5 from both of the value over there. As for part 2, okay, this is slightly complicated and you're required to take note on this. Whenever you saw square, okay, you're required to expand it first. So what we have there after the rearrangement will be integral to 1 x squared plus 2 over x plus x to the power of negative 4. So I anti-differentiate it, or I just apply integration into it. Then you get 1 over 3 x cubed plus 2inx plus 1 over 3 x to the power of negative 3. And I know that a lot of you are confused on this steps. How did I get to 1 over 3 x cubed? Where did I find the 2inx? And also, why is it negative 1 over 3 x to the power of negative 3? So I written down it at the side. So let's say we are given dy dx equals to x squared. So the y of it after the anti-differentiation will be y equals to unknown x cubed. I set the unknown over there so that I can identify it later on. So unknown times 3 equals to 1. This is the process where I take this y that I identify and differentiate it to get to dy dx. The 1 is actually the numbers in front of the dy dx x squared. So by running the calculation, I'm able to prove that the value in front of x cubed will be 1 over 3. So x squared will be changed into 1 over 3 x cubed. So I repeat the same for the next one. We have 2 over x. Through these rules, this table that I'm showing you here, you will know that 1 over x can actually be written as inx, and the 2 doesn't change. So y equals to 2inx will be its original form. And we have x to the power of negative 4 over there. So I set down y equals to unknown x to the power of negative 3. Okay, because from negative 3 minus 1, then you get to 4. So unknown times negative 3 equals to 1. Unknown equals to negative 1 over 3. That's how I gotten the negative 1 over 3 x to the power of negative 3 over there. Substitute 2 and 1 into it, then you will get your final results as 2in2 plus 21 over 8. As for part B, same thing, I set down dy dx equals to 1 sine x over 6. Then I written down y equals to unknown times negative cosine x over 6 plus c. So let's focus at the front. Let's say if I were to extract 1 over 6 out, multiply with the unknown, it will be results to 1. So unknown will be 6. So the anti-differentiation of sine x over 6 will be negative 6 cosine x over 6 plus c. This c, we couldn't identify it because we don't have sufficient information. However, for certain types of question, you are required to identify the details. Over in question 9, this is the expansion. Okay, so they wanted the coefficient of x to the power of 4 is 10 times the coefficient of x to the power of 2. So I listed down the first 5 terms of the equation given to us, and I identified the one with x squared and x to the power of 4 is the third and the fifth term. Extracted the fifth term at the front, so I got nc4 times 1 to the power of n minus 4 times 16. This is the coefficient of x to the power of 4, and it is 10 times, okay, so I put a 10 over there, then multiply with nc2 times 1 to the power of n minus 2 times 4. This is the coefficient of x squared. Okay, so nc2 can be expanded into n bracket n minus 1, n minus 2, n minus 3 divided by 4, 3, 2, 1 times 16. The 1 to the power of n minus 4 automatically cancel off because 1 to the power of anything will still be 1. Same goes to the other side. The nc2 is expanded into n bracket n minus 1 divided by 2 times 1 and multiply with 4. After the rearrangement and details calculation that I showed over there, you will get your final results as n squared minus 5n minus 24 equals to 0. Factorize it accordingly. Then they are looking for the positive integer. So the negative 3 doesn't qualify, so I didn't even mention about it. So the only answer for this question with a 6 marks in total will be n equals to 8. So question 10 in arithmetic progression has the first terms of 5 and a common difference of negative 3. Find the numbers of terms such that the sum of the n term is first less than negative 200. So a couple of things that I identified here was the a is 5 and the d is negative 3. And the other thing was the sum of n term is less than 200. Okay, so this formula that I've written down over here is available in your exam. Okay, so it's just at the first page that we went through earlier. So I construct the equation that goes by negative 200 more than n over 2 bracket, substituting our a and d's value into it, then you get 2 bracket 5 plus n minus 1 times negative 3. After the calculation, you will get negative 400 more than n bracket 13 minus 3n. Multiply the n into the bracket and rearrange them, you will get 3n squared minus 13n minus 400 more than 0. Okay, so I use quadratic equation over here, negative b plus minus square root of b squared minus 4ac over 2a. Then you get your final results as 13.9158903. So to correct this into term, I rounded it out into the 14th term because they wanted it to be less than. Part B, a geometric progression such that third term is equals to 81 over 64 and the fifth term is 729 over 1024. So u3 equals to 81 over 64. I can write it as a, which is our first term, and r is our common difference, to the power of 2 equals to 81 over 64. And the other side will be a times r to the power of 4 equals to 729 over 1024. So I divided these two variables against each other. Then I gotten the final value as r squared equals to 9 over 16. And by square root this results, you will get r equals to 3 over 4. Substitute this 3 over 4 into r's position. Then you will get your a as 9 over 4. You can substitute this 3 over 4 into either one of them. You will still get the same results. As for part 2, same thing, the equation was given at the front. Substituting our a and r's into the respective position, you will get your final results of s to the infinity is 9. Pretty straightforward. This is why it only has 1 mark. Question 11 that we have over here, okay, this is the complicated types of differentiation and anti-differentiation. Okay, so as per usual, when I come across this type of question, I usually identify what shapes involved here. Okay, so I immediately identify a trapezium. So to calculate the area of the trapezium, I need the a and b's coordinate. And this a and b over here is where the line y equals to x plus 10 intersect with y equals to x squared minus 4x plus 10. So when they intersect, okay, which means these two equations is equivalent to each other. So by running the calculation, you will get x equals to 0 and x equals to 5. So a's value will be when x equals to 0, so the coordinates of it will be 0. As for b, will be when x equals to 5. Substitute this value into either one of the equation, you will get the same results of 10 and 15 respectively. So now we have our a as 0, 10 and our b as 5, 15. So the trapezium of this OABC will be the top of 5 plus the bottom of 15 divided by 2 multiplied by the height of 5. So from this, you will get 62.5. Moving on, I will be calculating the area under the curve. Okay, because the integral or anti-differentiation or integration of the equation x squared minus 4x plus 10 will get you the area under the curve. So with the range that we identified, which is a and b, I can now put 5 at the top, 0 at the bottom. So the anti-differentiation of x squared, I've written down at the side, my dy dx, I set it as 1x squared, y equals to unknown x cubed. Why is it cubed? Because the previous term power must be bigger than the differentiated ones. So unknown times 3 equals to 1. So my unknown here after the calculation will be 1 over 3. So moving on to the negative 4x that we gotten, I set dy dx equals to negative 4, my y will be unknown times x squared. So unknown times 2 equals to negative 4, my unknown will be negative 2. So now what we have over there will be negative 2x squared. As for the last one, we have only 10 over here. So this 10 is actually multiplied with x to the power of 0. So my y over here will be unknown times x to the power of 1. So unknown times 1 equals to 10, unknown equals to 10. So we have plus 10x over here. Substituting 5 and 0 into it, find the difference, you will get 125 over 3. So since they are looking for the AB shaded part only, so I took the whole shape, which is trapezium area, minus off with the area under the curve. The difference here will be 125 over 6, or you can write it as 25 over 6. So this is how you solve this type of question, and it is worth 8 marks in total. So this is pretty much it for this specimen paper number 1. Okay, a lot of the question is actually they selected from previous past year, and the major difference between this 2020 syllabus compared to the previous one is that sets was being removed. Okay, there's no more matrix question here, as well as there's no the direction question that previously a lot of students struggles to understand. Overall, now the syllabus is being shifted backwards to papers from 2015, and a lot of question is actually easier in my perspective. So I hope that you're able to solve this entire set by yourself. So hopefully you find this explanation helpful, and your friends that are struggling, feel free to share this to them. I wish you all the best in your upcoming examination. Thank you.